Okay, so for the next topic is we have the advanced techniques. So if your basic process such as your U sub or the basic formulas does not apply to your equations anymore, so that's a time that we are going to use advanced techniques of integration. So we have four, and we're going to tackle each topic, hopefully one topic per week, so that we can absorb it fully in our system. So di lang nato ikaliton in one go. So we have four different techniques of integration. So we have algebraic substitution, trigonometric substitution, integration by parts, and integration by partial fraction. So since we have four, so the four techniques pertain to different scenarios. So it may be that you can use two advanced techniques in one equation, or you can use three. So it depends on how long the integration process takes for you to be able to reach your answer. So let's start first with algebraic substitution. So in your algebraic substitution, so this is more likely the same as your U substitution, your U sub technique, but I think the only difference here is there's one extra step in your algebraic substitution, and usually what we try to eliminate in your algebraic substitution are your radical expressions, kanang mga square root functions, cube root functions, mga root functions. That's we try to eliminate in your algebraic substitution. And usually, the objective of your algebraic substitution is for you to be able to reach a simple version of the given equation. So in the U sub, the objective of your U sub is for you to be able to reach a basic formula so that you can use the formula. But in your algebraic substitution is from the given equation, you'll be able to reach a simple version or a simpler version of the equation given to you. Okay, so if you're going to read the description, so most of this is the same as the U sub technique. Okay, so again, there are no general rules in the sub technique, and the only skill that you can acquire from this one is from practice only. Sorry. Okay, so let's try to solve the seven different examples. So as you can see in the given example, so all of which have radical expressions or radical terms. So we have square roots, cube roots, fifth roots. So that's why, so again, the aim of the algebraic substitution is for us to eliminate the radical expressions and then reach a simple version or a simpler version of the equation without any radical terms anymore. Okay, so let's begin with the first example. So notice that if you try to use U sub, so let's try to use U sub first before we're going to use the algebraic substitution technique. So let's say we're going to let U be equal to 1 plus x. So derivative of U is equal to dx. So notice that we can replace your 1 plus x with u and then your dx with the du parameter. So what's left for us to replace is square root of x, but we cannot replace anymore your square root of x because we have already completed the u sub technique. So meaning we cannot use this particular u declaration here. So what if we let u be equal to square root of x? So in exponential form, that will be x to the power of 1/2. Then this will be the derivative of your u function is 1/2 x to the power of negative 1/2 dx. So notice that we can represent your square root of x with the u function. But our problem here is our dx, because our dx is paired up with 1/2 x to the power of negative 1/2. Or if you try to isolate your, so this becomes dx all over square root of x, diba? Then the other side is 2 du. So notice that in the remaining terms above, so we don't have any dx all over square root of x. So again, the u sub here is not applicable. So that's the time that we're going to use the algebraic substitution technique. So usually if I tell my students that if you see a radical expression or a radical term, use immediately the algebraic substitution technique. But of course, it doesn't apply in all cases, because there are some cases that you have a radical expression in your integral, but it can be solved using a simple u sub. So that's why you try to observe first or do some trial and error method for you to be able to determine what really the process is for this particular integral. Okay, so in algebraic substitution, so we're going to represent your variable. So instead of letter u, so we're going to represent it with z variable. And again, we let the complicated term. So since we're trying to eliminate the radical expression, so we're going to eliminate the square root of x, because muna siya ang radical term. So we let the radical term be the z variable. So next step, so again, instead of getting the derivative immediately of your z variable, so before deriving, so we eliminate first the radical expression by squaring both sides. So we have z squared. So on the right side, we eliminated the square root function because we multiplied we square everything in the equation. So this becomes x. So after eliminating the radical expression, so this is the time that we can now get a derivative. So this becomes 2z dz is equal to dx. Okay, so if we try to verify it above, so your square root of x can be represented by the z variable. Your dx can be represented by 2z dz. Your x variable can be represented by z squared. So of course, the 1 here won't matter because this one is a constant. As long as we converted every term into the z variable, so it's okay for us to proceed with the process. Okay, so next is if we try to write the new format. So square root of x is now the z variable. Dx is 2z dz all over 1 plus z squared. So factoring out the constant term 2, the numerator is now z squared dz all over 1 plus z squared. So next step is, again, if you remember your algebra, So dividing algebra, dividing algebraic terms. So since our numerator and our denominator has the same degree, so notice that this one is second degree, denominator is also second degree. So if the numerator is equal of degree with the denominator, or the numerator has a higher degree than the denominator, so we can divide the algebraic terms. So if you have forgotten how to divide algebraic terms, so just imagine or just recall your long division, because the process of dividing algebraic terms is the same as your long division. So katong mga synthetic division are those are advanced techniques in dividing algebraic expressions. Okay, so dividing, so we have z squared divided by 1 plus z squared. So we have 1, then z squared plus 1, and then minus, di ba? Mura tag nag-long division ra sa kanang atuang elementary. Diba? So kanang mga big numbers divided by a small number, then we use a long division. So this will be negative 1. So again, if you try to recall how to write your quotient plus the remainder, so this becomes the quotient, then plus the remainder. So plus the remainder all over the divisor. So plus lang. So even though it's minus, so plus negative 1 man siya. So may mo siyang minus, di ba? 1 plus z squared. So this is your quotient plus the remainder. Okay, so ngayon na minus. So again, if you have forgotten the process, so again, so multiply, di ba, z. So this becomes z squared plus 1, di ba? Then of course, minus man na, di ba? I-minus man na nimo. So minus z squared minus negative 1, di ba? Muna, negative 1 siya dire. So 1, the quotient, 1. Then minus the remainder, di ba? So plus 1 man na ta, plus minus 1 man ta na. So ako lang siyang gi-minus dito. So kay mamragana siya ba? 1 plus negative 1 over 1 plus z squared, di ba? So ani gyapon siya pagka-present. Okay, di ba mga long division, di ba? Atong inon na mga 383 divided by 2 ana, di ba? So 1, then 2, di ba? Nya ato man na yung minus, di ba? Nya 9, di ba? Ana man na pag-divide sa una, di ba? Nya 0, nya 3, di ba? Ana man na siyang long division. 1, nya 2. Nya minus na to, di ba? 1. Nya ang remainder is 191. Nya and 1/2, di ba? Ana man na siya pagkasuwat, di ba? But since we are dealing with algebraic terms, so ato siyang i-minus, di ba? So okay na siyang portion. Okay, so ato sang i-erase ka dito, ha? Para natay space. Okay, so the new equation is now 2 integral of 1 minus 1 plus z squared dz. So take note that in the first integral, so 2 times the integral of 1, so we can immediately get an answer of, so let's try to, so if we try to distribute the first, or we integrate the first term, this results to z, di ba? In the second term, so how do you integrate 1 over 1 plus z squared? So integral of 1 all over 1 plus z squared dz. So if you have not forgotten what we discussed in the last meeting, last meeting siguro. So this one is in the format of arctangent, diba? So du all over a squared plus u squared. Okay? So a squared being 1, a is 1, u squared is z squared, so your u is z. And the answer for this particular format is again in inverse trigo. That's 1 over a arctangent u over a plus c. Diba? So getting the final answer, so we have 2z, so minus 2 times 1 over 1 arctangent z over 1 plus c. So 2z minus 2 arctangent z plus c. So again, don't forget to bring back the value of the z parameter. So the final answer is 2 square root of x minus 2 arctangent square root of x plus c. So this is the final answer. All right, so questions? Okay, so I think there's no question. Okay, ngano na 2z. So 2z siya because dire kaning first integral kani siya. Kani. Diba? Integral of 1 is z man, diba? 2z. Okay, so any further questions? Okay, so wala na. So let's proceed to the next example. So we have the integral of 1 all over x minus square root of x with respect to x. So again, if you try to use u sub, diba? So marag lisod siya kay let's say x minus square root of x. So you're going to have du is equal to dx minus 1 half x to the power of negative 1 half, diba? And looking at your dx, diba? So this term can be replaced by u, but your dx is the only term left in the equation. And looking at your derivative of u, so we have an extra term here on the right side. So dili siya pwede, diba? So how about if we let u be equal to x? So du is equal to dx. So we can replace dx, we can replace x, but we cannot replace your square root of x. So still not okay for letting u be the x variable. So what if u be equal to square root of x? So derivative is equal to 1 half x to the power of negative 1 half dx. So we can replace x, but looking at your dx, we don't have an extra term here, cutting 1 half square root of x, di ba? Dx. What ay extra nga square root of x in the denominator. So we cannot use this term also. So again, if you come across a radical expression So matik na nga kuan. Automatic nga ditso na ka sa kuan sa algebraic substitution. Oops, sayop tayo. Sorry. So z is equal to the square root of x. And again, before deriving your z parameter, eliminate first the radical expression. So this becomes z squared is equal to x. So again, I squared everything so that I can eliminate the radical expression here. So after eliminating the radical term or the radical expression, so we can now derive. So this becomes 2z dz is equal to dx. Okay, so notice that in the numerator, we can represent this one with 2z dz. Your square root of x can be represented by the z parameter. Your x can be represented by z squared. So every term can be substituted with the z parameter. So in the new format, so you have 2z dz all over z squared minus the z parameter. So isolating or factoring out the constant term, so z dz all over z squared minus z. So notice that we can still factor out one z in the denominator. So 2 integral of z, so z dz, z times z minus 1. So you can eliminate 1 z. So we now have 2 dz all over z minus 1. So if you're not sure if, so usually since I've been teaching this course for quite some time, so upon looking at the equation, so I can tell that this one is automatically ln. So if you want to verify for yourself, so you're going to use u sub. So getting the derivative, du is equal to dz. So this term is your u parameter, numerator is du. So so everything can be replaced. So this becomes 2 integral of du all over u. So that's why it's ln, diba? ln u plus c. Then bringing back the value of your u parameter, that's z minus 1 plus c. Then bringing back the value of z, that's ln square root of x minus 1 plus c. So muna siya. So again, looking at the blue kaning algebraic substitution, the objective of which is for us to reach a simpler version of the equation. So from this term here, dire, di ba? And then the objective of your u sub is from this term here is you go to a basic formula, di ba? Ano siya? Basic formula naman siya, du over u. So muna siya ang difference. And the difference also in the process of algebraic substitution and your u sub is before, so in the first step, it's the same, declaring one term be the variable. But in the second step, in the u sub, idiretso siya og derivative, di ba? But here in the algebraic substitution technique is we eliminate first the radical expression before we derive it. So there's an extra step in the algebraic substitution. So usually what we are targeting in the algebraic substitution is the radical expressions, eliminating the radical expressions. Okay, so questions? So, ang naka-square root na term, if mo i-equate pirmi sa z, in most cases, mo na siyang inyong equate. So, because there are other problems nga dili lang square root ang given. So, it could be any root, di ba? So, it could be cube root, it could be fifth root. Basta as long as you equate the radical expression in the z. So, you're not limited only with the square root. So, pwede siya cube root basta it's the radical expression. So, radical expressions are kanang mga root functions. Okay? So, let's proceed. So, we have the integral of x cubed times the square root of x minus 4. So, let's try to go immediately with the algebraic sub since we are seeing a radical expression. So, di na ta paligoy-ligoy pa na. But of course, if dili siya, just try to observe lang jud the equation because again there are cases wherein you can use the u sub rather than using the algebraic sub. So basta niya makita mo og kanang radical expressions, you won't try to solve it using u sub. So basin pwede siya u sub, di ba? So as you can see here, I think it's difficult for us to use u sub because this one is x cubed, and if you can get the derivative of x cubed, that's 3x squared. Then the remaining term here is kuan siya ng radical expression, or if you get the derivative of x minus 4, so that will be dx only, and you still have an x cubed left inside your equation, so di siya pwede, di ba? So basta ka murag mangyara na ma-discover later nga di siya pwede na kuan siya, more practice na siya. Okay, so square root of x minus 4. So again, getting the square of both sides, this becomes z squared x minus 4. And then we get the derivative. So 2z dz is equal to dx. Baka dx minus 0 naman siya. So your z parameter is this one. Your dx is your 2z dz. So how about your x cubed? So of course, we can isolate this one here. So z squared minus plus 4 is equal to x. So your x variable can be represented by this one. So may mo lang siyang x cubed, di ba? Ini ka replace na to sa z variable. So substituting. So the first term is the x term here, kani siya, di ba? So z squared plus 4, and then cube, di ba? Cube times x minus 4, square root of x minus 4, that's the z variable. Then dx is 2z dz. Okay, so factoring out the constant, that's 2. Then you have z squared plus 4 cube. Then you have z squared dz. So ako lang yung gi-combine ni ani. Then kaning to is akong i-factor out sa gawas. Okay, so next step is, I think for us to expand this one, so I think we can expand up until cubic binomials, di ba? Kay murag wala na siya ang atong ang gitudlo sa ato sa high school. We can manually expand up until the cubic degree. So if you're expanding greater than the third degree, so I think you're going to use Pascal's triangle. Pascal's triangle. So if you try to recall Pascal's triangle, so mo to siya katong 1, 1, 1, di ba? 1, 2, 1, 1, 3, 3, 1, so on and so forth. Up until magkadako ang inyong degree sa inyong polynomial. Okay, so since this one is just a binomial to the third degree, so let's take it step by step. So let's try to, so ano naman na siya, di ba? Z to the power of 4, z squared plus 4, z squared plus 4, then you have z squared dz. So expanding first the first two binomials, so this becomes z to the fourth plus 8 z squared plus 16, di ba? Z squared plus 4, then z squared dz. So next na po, di ba, kanina sad. So para di maglibog, para sure inyo hangkuan for your answer to be sure, so just go very basic by distributing one term at a time. So let's try to multiply first z squared. So z to the 6 plus 8z to the 4th plus 16z squared. So next is we distribute 4. So 4z to the 4th plus 32z squared plus 64. Then we have z squared dz. So combining like terms, so mataga algebra, di ba? So we have z squared, z to the 6, I mean, plus, so combining like terms, so you have 12z to the 4th plus, so squared na sad ta, di ba? Plus 48z squared plus 64, then z squared dz. Then we expand the last one by multiplying z squared. So this will be your final format. So even though it's long, so I think you can manage to integrate the terms here because you'll only be dealing with the exponent rule. Ba? So mana siya, di ba? So don't forget to multiply 2 to every integration process. So 2z to the 9 over 9 plus 24 z to the 7th over 7 plus 96. So 48 times 2 is 96. So to the power of 5 over 5 plus 128 z cubed all over 3 plus c. So don't forget to, again, bring back the value of your z parameter. So usually so if parnako, if the square root function or the radical expression is an algebraic expression, kanang taas siya ba? X minus 4. So I represent it in the exponential form lang. X minus 4 and then 9 halves. Ana ako lang yan na siya. All over 9 plus 24 x minus 4 7 halves ana over 7 plus 96 x minus 4 5 halves over 5 plus 128 over 128 times x minus 4 3 halves over 3 plus c. So ako lang siyang inaana kaya para nindo tanawon ba. So depende rin na sa inyong taste if how you want to express your final answer. So you can also express it in this manner. So 2 square root of x minus 4 to the power of 9 over 9. Pwede po na siya anasad. So on and so forth. Okay, one space. So pwede po na siya inaning a version. So this one is the exponential form. Exponential form meaning an exponent form. This one is in radical form, mga root form, mga square root, mga cube root. Atop pa, atop-atop ba? Atop-atop, di ba? All right. So do you have questions? Okay, so if z to the power, so if fifth root, sakto na siya. So if fifth root, so meaning you multiply to the power of 5 para makancel ang fifth root. Sige lang, naman tayo example na niya. Okay, so for this example, do you have questions? Okay, so ang midterm is, I'm not sure when the midterm is, but I think mga next month siguro. Because if we're still on the first month, siguro 1 month plus pa ta sa atong semester. Usually the midterm is, so usually in a semester 6 months, di ba? 6 months. So sa third month pa na ang midterm. Okay, so next example ta. So muna siya katong inyong pasabot kanina. So we now have the integral of x times the fifth root of x plus 1 squared. So challenge na di ba? So again, algebraic sub. So let the radical expression be the z parameter. So this will be the fifth root of x plus 1 squared. Or for you to be able to easily multiply it with the power, so express it in the exponential form. So this becomes x plus 1 raised to 2/5. Diba? So again, multiplying it with a certain power for us to eliminate this one. Diba? So muna siyang process jud of kanang multiplying it with the power. So multiply everything with the power of 5 halves, diba? So ano 5 halves man? Because we need to eliminate the term here. Ano siya? Diba? Kay 2/5, diba? Power to power is you multiply directly the exponents. So that's why we're going to use 5 halves. So this becomes z to the power of 5 halves is equal to x plus 1. So next is, this is the time that we can now get the derivative because we have already eliminated the radical expression. So 5 halves, so z, so minus 1, so 5 halves minus 1, that will be 3 halves dz. And on the right side, that will be dx. So again, notice that your dx is this term here. Your fifth root function is the z term here. So how about your x term? So we're going to get your x term from here. So isolating the x variable, so you have z to the power of 5 halves minus 1 is equal to x. Now, all right. So far so good. So next is, so again, your x variable, the first variable to be replaced is z to the 5 halves minus 1. Then the square root of, the fifth root of x plus 1 squared is your z parameter. And then your dx is 5 halves z to the 3 halves dz. So we can try to factor out the constant first. So that's 5 halves. So integral of z to the power of 5 halves minus 1, then times z, then times z to the 3 halves dz. So if you try to combine z and then the z to the power of 3 halves, so we're going to have 5 halves. So ato lang siyang step by step para makita ninyo ang process. So wala may di kasabot og Bisaya diri no? So 1 plus 3 halves, again, exponents, then having the same base. So meaning you can just add up the exponents. So 1 plus 3 halves, that will be z to the power of 5 halves dz. So next step is for you to distribute z to each term here. So you have 5 halves. So z. So 5 halves plus 5 halves is ilaman? 5, di ba? Because that will be 10 over 2, and then 10 divided by 2 is 5. Then minus z to the power of 5 halves. Then dz. So looking at your new equation now, so it can be integrated using basic formulas. So this becomes 5 halves. So again, don't forget to multiply 5 halves to each integration process. So times z to the power of 6 all over 6. Then minus 5 halves. So z, so plus 1, that will be 7 halves all over 7 halves, diba? Plus c. So cancel out 2, cancel out 2. So what remains is 5z to the 6th all over 12 minus 5z to the power of 7 halves all over 7 plus c. So don't forget to bring back the value of the z parameter. So in this case, since this one is a complicated radical expression, so I suggest that you use the exponential form in exponent version, and then the radical version, di ba? Muna siya. Para di mo maglibog. So 5. So again, this will be x plus 1 raised to 2/5, di ba? And then, inyo rin apply ang 6th power. Ana, di ba? Then minus 5. So again, exponential form. X plus 1 raised to 2/5. Then apply the power, which is 7/2 all over 7 plus C. So notice that in the first term is that becomes 12 over 5. This one becomes 7 over 5 because we can cancel out 2. So the final answer is 5 x plus 1. So di ba, mark na siya napa-advantage if you're going to use the exponential form or the exponential version. So 12 over 5 all over 12 minus 5 times x plus 1, 7/5 all over 7 plus C. So this is the final answer. So I think ang inyo yung kontra in the integration process is most likely algebra jud. Ba murag kuan kay siya. Okay. So do you have questions for this one? Okay, so no questions. So let's try to proceed with the next example. Okay, so this time is we have the integral of x all over cube root of x plus 1. So again, we try to proceed immediately with the algebraic substitution. So again, a tip here is you try to observe first if you can apply the use sub technique. So if not, so meaning you need to use advanced techniques na. So z is equal to the cube root of x plus 1. So again, getting the cube root or getting the cubing all the equation. Cubing all the equations. So I'm just going to show you how. Diba? So this becomes z cubed all over x plus 1. And so next is we're going to get the derivative. So this one is 3z squared dz is equal to dx. Okay. So this one is represented by the z. Your dx is represented by 3z squared dz. So your x variable, the remaining variable here, so you can isolate the x parameter here. So z cubed minus 1 is equal to x. So the x parameter here is this one. Okay, so you can now start with the substitution process. So the x variable again in the numerator, that's z cubed minus 1. And then dx is 3z squared dz. Okay, then divided by the cube root of x plus 1, that's the z variable. So you can eliminate or cancel out one z, and the expression becomes even simpler. So factoring out 3, then we have z cubed minus 1. Then this one is z dz. So of course, distributing your z, so for it to be more simpler, so you have 3 integral of z to the fourth minus z dz. So integrating is, again, don't forget to multiply 3 to each term. So 3, then the integral of z to the power 4, that's z to the fourth all over 5, minus 3 times the integral of z, that's z squared all over 2, plus c. So this becomes 3z to the fourth over 5 minus 3z squared over 2 plus c. So again, don't forget to write back the value of z. So again, I like writing it in exponential form because we have a binomial. So there are other cases that it's okay for you to write it in radical expression. For example, x variable lang siya, so that's okay. So 4 thirds all over 5 minus 3, so x plus 1, then 2 thirds all over 2 plus c. So this is the final answer. Or if you want it again in radical expressions, so magbutang pa mo parenthesis. But you have to be very careful in writing. You don't have to forget the index of the root expression. Na, di ba? Na, cube root, di ba? Muna siyang index, di ba, of the root functions. Di ba? Muna siyang index. Na, square, di ba? So you can write it in that manner also. Okay, so questions. So na questions sa previous answer, previous problem. So sa may kuan, sa may question. So kani siya kay over 2 daw, na over 2 niya. So sakto ni siya, over 2 ni siya. So unsay question sa previous kuan? Oh, what's that? Magnasayop sa go. What's that? So kani siya is to the power of 5 din siya. 5, then 5, 5. Na, so sakto na, no? Sakto na siya, no? Sakto na. So sa previous example is sa ano substitute kay raised to 2/5, so tanaw na. Ang na-substitute kay 2/5. Sakto man, 2/5 man. ang igamit na ko kay 5 halves kay pang-eliminate lang sa kuan kani ba? Diba? Kay kailangan to eliminate ang kuan man, ang exponent. Diba? So pag-convert una is x plus 1 raised to 2/5 siya una. Nya kailangan to siya eliminate, diba? Eliminate the radical expression. So muna ato siyang i-multiply yan og 5 halves na ba? Muna dire natay 5 halves po dire sa z. Nya sa right side is 1 na ang 5 ang 2/5 kay power to power man, di ba? Exponential rule, exponential property, di ba? Di ba sakto ko, sakto? Or sayop? Or na-address na ko imong kuan, imong question? Na kuan ra na-address ra? Ah, sige. Okay. So, questions pa? Napay questions line. By the way, if nakasabot sa mga Bisaya, no? Basin, muna ka ni ba itong klase na Korean? Or katong ako ang kalimot man ko yung masaya makalimot ko magbisaya ako ba niya na ko mag-English di ko dapat or basin ay taga Bacolod ani no kalimot mo ko sa lista gud wano ko check nagamog mga foreigners may mga foreigners dire or basin ninyo mga foreigners po diya kay mga Chinese ra po di ba mga Chinese na Pinoy sad kay ang apelyido mga Chinese di ba sige lang so ako lang ikuan kasi makalimot ko kuan good English na maglami nagstorya ba sige kay gutom na murag ato ning human na so example number 6 ata kay para makakauntag sa iyo okay so z here is the cube root of x squared plus 4. So ano basa-basa equation no ana. So usually ana man ta basta mag-solve equation no. Ang tanaw sa kuan solve it so ana. Ano daghalangan. Hindi na basahon ba di ba? So again, getting the cube of the equation. So this becomes z cubed. On the right side is you have x squared plus 4. So again, getting the derivative. So you have 3z squared dz is equal to 2x dx. So if we can verify the terms above, so cube root of x squared plus 4 can be replaced by z now. Your dx, if you try to observe on the derivative on the bottom side, is you have x dx, 2x dx. So where do we get the extra x from the equation above? So instead of x cubed, let's try to break it down into x squared times x. So we can borrow 1x to pair up with dx. Okay, so instead of 2x dx, so this becomes 3 halves z squared dz is equal to x dx. So this term here, x dx, can now be represented in the equation above. So what's left for us to replace is your x squared now. So again, notice that the equation is still balanced because if we try to combine x squared plus x, it leads us back to the original equation, which is x cubed. Okay, so getting x squared, so we need to isolate x squared. So z cubed minus 4 is equal to x squared. So this is where you get your x squared. So again, it won't matter if um, you're going to replace x with just one x variable, then square nyo later on. I think it's the same example as example number 3 man siguro to. Itong x, then mo siyang cube, di ba? So as long as you transform every variable into the z parameter. So that's the most important tip for this process. So I think it's the same for the u sub, that you need to replace every term in the equation with the new variable. Okay, so getting the new form, so x squared, that's z cubed minus 4. Then your x dx is 3 halves z cubed, z squared, z squared. So klaro na kayong gutom no, kay sayop-sayop na. So 3 halves z squared dz. And then the denominator is the z parameter. So we can cancel out 1z, cancel out 1z. And we can factor out your 3 halves outside the equation. So 3 halves, then integral of z cubed minus 4 times z dz. Sige tag nalipo na tani kay sige tag ka dz, di ba? So pasensya na kayo sa mga dad jokes ha. So 3 halves and then distribute. Distribute. So z to the fourth minus 4z dz. So I think we can now integrate each term. So again, don't forget to multiply with 3 halves with each integration process. So the first one is 3 halves times z to the fifth all over 5 minus 3 halves times 4 times z squared all over 2 plus c. So cancel out 4, di ba? Okay, 2 times 2 is 4. So final, so almost final there. Almost final answer. 3z to the fifth all over 10 minus 3z squared plus c. So again, don't forget to replace again the value of your z parameter. So 3. Then we have x squared plus 4. So again, I like writing it down in exponential form. So depende na sa inyong trip o kung sa inyong gusto may tabo sa inyong final answer. Basta as long as it's logically correct sad. So 5/3. Okay. All over 10 minus 3 x squared plus 4, and then that will be 2/3 plus c. So muna siya ang final answer. So again, if you've forgotten how to shift from radical form into exponential form, so just try to search online the radical properties, exponential properties, and radical properties. Okay. So do you have questions? Let's see if you have questions. Okay, so wala ra. Okay, so let's proceed with the last example. So this one is a difficult example. So usually if we try to, let's say, let z be one square root function, so let's say cube root of x, di ba? May mo siyang z cube is equal to x. So notice that we can only eliminate one square root, di ba? I mean one root function. Ang square root, mahabilin, di ba? Yeah. Either way, if we let z be equal to square root of x, so notice that upon getting the squared, so we can eliminate this one, but we can't eliminate the other root function sa, di ba? So murag lisod na, lisod. Nahihirapan ako sa kalisod, di ba? So what we need to do here is we need to express your z into one radical expression that can eliminate both radicals in one go. So ma-eliminate siya in one go. Kaning z, kaning square root of x, and then cube root of x. So usually what I do here is for me to be able to imagine what particular root function I'm going to represent as z. So I'm going to represent this one as in exponential form. Then the other one is 1 to the power of 1/3. Then usually I just multiply the powers. So meaning I need to represent it with x to the power of 1/6. So ako lang siyang inana lang. So dili siya add, dili po siya multiply. Basta I'm just looking at the exponents. And then if I multiply the exponent, so that will be my z parameter. So wala siya kanang, how do you explain this? It's a trial and error method, but I think it works because you can eliminate both radical expressions. So this one is not really a procedure, but it's more of a, I think you need to discover it on your own, that you need to eliminate both radical expressions in one go, and you need to represent your z with a particular root function that can eliminate both radical expressions given in the equation. So murag lisod ka English no? Ato na tanaw og sa makaya ba sa Bisaya? Murag og sa Bisaya ba siya? Murag kailangan ta og z nga expression. We need one z expression nga maka-eliminate sa square root of x and sa cube root of x. Na og sa Binisaya pa. Murag dunganon siya og eliminate ana. You can eliminate it in one procedure only. Ang lisura mag-English no ya. Mag-engineering naman ko para kuan. Okay, ganahan kog math. Okay, so muna siya nya. So if you try to observe, so let's say 6th root of x. So this is x to the power of 1/6, di ba? So meaning if I multiply it with the 6th power, so this becomes z to the power of 6 is equal to x only, di ba? Okay, because we can multiply this one power to power. So next is we can derive, since we have eliminated the expression. So 6z to the power of 5 dz. Diba na dz na dito ni. Pinaka-last na dyan nga dz. Last na lang dyan ka. Kay gutom na dyan. Okay, so if we try to verify, so x here is, dx here is your 6z to the power of 5 dz. So even though you don't have a square root of x to represent your z, diba kay dapat z is equal to 6 root of x. So bahala na siya diha. Basta ang atong ibutang diha, we're going to replace x with z to the power of 6. Na z to the power of 6 Yan, ma-measure mo later na mawala ra ang mga root functions. Okay, so 1 all over the square root of x. So this one is the x parameter. That's z to the power of 6 plus the cube root of z to the power of 6. So dx is 6z to the fifth dz. So muna siya. Diba? Kung tanawin ninyo, we can now eliminate the radical expression because we have z to the power of 6, square root of z to the power of 6. So in exponential form, so let's try to put the dz in the numerator. So 6 outside the equation, then this one is z to the fifth dz. So this one, if in exponential form, 6 all over 2, di ba? Plus z 6 all over 3. So notice, nawala na ang radical expression. So z to the fifth dz all over z cubed plus z squared. So you may not able to absorb this one as of the moment. Okay, kibaw ko, gutom na kayo mo. So just try to go back to the recording later. Kanang busog-busog na mo, di ba? Para ma-absorb nyo balik. Basta ang aim is for you to eliminate the radical expressions. Namura dyan na siya ang aim. Okay, so factoring out your z squared in the denominator. So z squared. So z plus 1. So cancel out. Then this one is cube only. So you have 6 integral of z cubed dz all over z plus 1. So again, notice that we have a big degree in the numerator against the denominator, so we can use long division. So sige lang, hapit na. So z plus 1, then z cubed. So first is z squared, that will be z cubed plus z squared, and then minus. So what is left is negative z squared. So minus z na sad ta. So minus z squared minus z. So you have z here, then plus 1, z plus 1, then negative 1. So final answer for the long division is z squared minus z plus 1 minus 1 all over z plus 1. Okay, so instead of the one above, so your new equation becomes 6 integral of z squared minus z plus 1 minus 1 over z plus 1 dz. So again, don't forget to multiply. Nabalik-balik jud ang inyo, no? Don't forget jud, don't forget. Nga ma-forget ra day. 6. So 6 times z cubed all over 3, di ba? Minus 6 times z squared over 2 plus 6z. So again, may ani na mga format, that's ln. So ayaw lang ko sunda kay ako na ni siyang experience na siya nako nga ln jud siya. So just verify for yourself na ln siya basta para nako ln siya. Okay, so this will becomes 2, this becomes 3, and then writing the final answer. So that's 2z cubed, then minus 3z squared plus 6z minus 6 ln z plus 1. So if we're going to replace the value of z, so this one is 2 times x to the power of 3 over 6 minus 3 times x to the power of 2 over 6, then 6 x to the 1/6 plus din minus 6 ln of x to the power of 1/6 plus 1. Oh, tadyo kayo, no? So this becomes the cube root. Kaya may mo siyang 1/3. Ala, aminog niyo ko itong computer. This becomes 1/2 din 1/2 din, 1/2. Square root. The other one is the cube root. So kani siya, maragbati man siya tanaw na exponential form because you only have one variable. But usually, I write it in exponential form if it's a binomial or trinomial or polynomial. So kani siya, since it's only the variable x, so I'm going to write it in the above lang adre. So I think it's better if you write it in this manner. 2 cube root of x. Square root lagi ang una lagi. Sorry na po. Then minus 3 cube root of x. Then plus 6. So 6 root of x. Diba? Marag mas gwapa siya tanawon, diba? If inanap po siya na format. So again, magdepende lagi na siya yung taste lagi. So na siya fashion gamay ang mathematics. Minus 6 ln of 6 root of x plus 1 plus c. Sama na siya ang final answer. Alright. So I think that's all for today. So if you don't have any more questions, so I'll be uploading the recording later. So ako siyang i-process sa kay napo ko recording sa ganinang 9 o'clock.